Welcome, everybody. Today is April the 18th, Dallas Personal Robotics Group, and we're going to walk around the table again and talk robots and robot-related things. We have a queue started tonight with Michael, then Ted, then Doug, then Pat, then open mic. So, Michael, what do you got?
Okay, mine's in my question. I'm going to make a statement, then I'm going to ask you a question. I've been working on that 6-can problems, like with the angles and things like that. And like Pat, I'm getting inconsistent angles, and so when I turned the wheels, I took it out of PID to just use PWM to turn the angle, and found out that my voltage is because I'm trying to go slow, that my voltage is so low that my motors are struggling to turn. Because until I bump it up a little bit, my question is, every now and then when I have it in a PID loop, I'll get that jerk, but sometimes I don't. So my point is, at that same speed, I'm thinking maybe I need to buy lower geared motors so I can go slow but have more voltage. Would that help? Does that sound like it makes sense? Because you know how you can turn your PWM down so low that your motors will stall? I'm right on the edge of stalling. So I'm thinking if I bought motors with a lower gear so I can use higher voltage with my PWM to do the same speed, if that might help correct my problem.
You mean to have a higher duty cycle where the PWM is on more?
Well, PWM is on more.
Yeah. It'll be the same voltage, but it'll be on more with a higher duty cycle. So
the motors will actually have more torque because they're getting more power. Does that make sense?
That's one definitely going to slower or more slower gives you to get the same speed, you got to have a higher setting. Okay. So
my point is,
that's very true. That's true. Another thing
go ahead, Doug.
The other thing that you might want to try is if you go back in the meeting chat notes a couple of weeks ago, we talked about how on Arduino you can change the PWM frequency.
Oh yeah.
You might want to try that through the different frequencies that are available for the timer that you're using for your PWM.
Okay.
And see if there's one that gives you a better response. Okay. That would be worth doing since you've already got these motors, and if it worked, but but you're right. If you buy higher geared motors, where your motor is slower,
spinning faster.
You have to, but you want to keep the same speed. You're going to have to spin faster.
I'm kind of thinking that's because when I took it and put it in PWM to get the same speed, I noticed these things are just struggling. So I'm thinking when I'm using the PWM, when I do PWM to do the same speed, not PWM, my PID loop to do the same speed straight, it'll straighten itself out and it'll do just fine. But if I'm just trying to do an angle or whatever, or turning, there's some inconsistency there with the turns. And when I took it to just turn it, one wheel going forward, one wheel going backwards, at that speed, those motors were struggling to turn that. So.
Well, what speed are you asking them to go at? I guess that'd be.
I don't know, just slow. I don't want them to go just slow. I don't know how to put it.
Yeah. Okay. So
You know how we run those robots kind of slow when we're trying to get them to do things.
You're going fast. When you're going straight, what speed are you? Just tell me what your setting is, or what you think you. I don't know. Are you using a velocity?
It's 60. It's on the PID loop. It's 60, but I have no idea what.
Okay,
what
that's fine.
That's fine. Of that is.
Okay, so 60. All right, and then when you try to do the turn, what do you ask it to do?
60.
60? The same 60?
The same 60. But that would be PWM. That would be 60 on PWM, and you know that's real low.
Yeah, but your PID loops will. The reason why you don't see it when you're in PID loop is because the PID it'll do whatever it takes to get you what you need.
Exactly. But I'm saying I'm with you. I understand all that, how the PID loop works.
So is your turn ballistic, Mike? Are you turning off the PID loop when you turn?
I did that as a test, to test it, to see why when I was using the PID loop to turn an angle, say 15 degrees, I was getting inconsistent. It would like the motor, the wheels would jump sometimes, and sometimes it wouldn't jump. And to me, that's something, I was getting inconsistencies with the PID loop. So I said, well, I'm going to turn this PID loop off and just use PWM and see how it acted.
Okay, now I'm going to ask you a question here. So you have a reference going into your PID, okay, which is I believe if you're using the Arduino PID program, it would be called. It's called set point. So now the question would be, are you achieving your turn by changing the set points to the motor? How do you tell it to ticks
of the encoder? I'm telling my encoder to stop at so many ticks. I'm measuring the encoder and saying that when this encoder, using millis, when this encoder gets to this certain tick, stop the wheels. But I've noticed that it would like even turn a little more than what it's supposed to.
Oh, okay. That sounds like that's if I'm okay. I'm just trying to understand. So when you do a turn, you drop out of your PID loop and you say, when these encoders go to these values, then stop. Is that correct?
Well, okay. Originally, I just used the same PID loop when I was making just an angle or a turn, a U-turn. I don't know if y'all remember, I kind of demonstrated my robot here a few weeks ago and went straight line and then made a U-turn and come back.
Mm-hmm.
Well, I left my PID loop on, and it works pretty good that way.
Okay.
But when I want to use that same, when I want to just do 15 degrees and not a full 360 or not a full 180 or just like 15 degrees, it's real inconsistent. And so that's with the PID loop on. So I said, man, what's going on here? As a matter of fact, I got real frustrated. So, which I bet everybody has in this group. But so
don't do the Weedebacker thing. The guy catches his
I pretend it's a Bud Light can.
What's funny? Anyway. What's funny when Carl was doing this earlier?
Yeah.
I said that reminds me of a new Bud Light commercial.
Well.
Anyway,
let's not go there.
Well, so Michael, do you have? You clearly have one PWM setting for each wheel, right?
Yes.
Yes.
And then do you have one PID loop for each wheel, or do you have one PID loop for direction?
I have one PID loop for each wheel individually.
So you have two separate PID loops.
No, separate PID loops. As a matter of fact, when I'm going straight, I've got to adjust the wheel just a little bit different. to go a straight line because of course the motors are. All right, let me do a little screen deal here. Presentation. You can see my code.
Really, the PID loop should be controlling the speed, right? So you
Yeah.
shouldn't have to adjust the.
You shouldn't have to
motor.
make any adjustment. I've seen demonstrations where the robot goes in a straight line and one wheel is this big and the other wheel is this big.
Come on,
And
let me do that.
it goes straight.
One of the other things to consider is a minimum speed with which you rotate. So
Yes.
in other words, don't choose a speed so slow that your PID loop can't really adjust it.
Well,
You got to
But
get
then you
up the
can't make
minimum
it so
speed of
fast
the motor.
because you'll overshoot your turn
Okay.
or your rotation.
Right, that's exactly what I'm with this because I think my set point's too low. Because
You break it
my set of vector, can you see my screen?
Yeah.
I'm trying to get it here.
See the there, 60 the
You're
left
breaking
and
up,
right
Mike.
anyway. Okay, let me shut this off. Ain't working very well. Stop presenting. Okay.
If you can pause your camera and share the screen, it might do better with limited bandwidth. So just mute your camera, which is the.
Oh, okay.
And
Don't-
60 is the percentage of PWM.
Say that again.
Is 60 the PWM percentage?
No, well,
That's the set point on the.
I'm not sure what units. Yeah, I'm not sure what units that Mike's using, but 60 is set point. So that's what the PID is trying. That's what the PID's trying to get to, 60, and one side's trying to get to 60.35.
Oh, so that's not the PWM he was talking about. If that's a set,
No.
it would be pulses per second or something.
Yeah,
The PWM is when I turn the PID loop off.
Okay, yeah.
Well, where does the output of the PID loop go?
Yeah, where are you?
We see the set
Do what now?
to fixed value, but what does the PID loop drive? So the PID loop output.
Well, I don't know. Here's the PID. Here's the PID.
No,
code
go to your motor control. I mean, your motor setting. Where's your motor?
Well, there it is, 33 and 34.
Okay, yeah.
Where's that?
It's the set point val output. So where do you compute val output left and right?
Left and right.
Yeah, the on lines
Right.
33 and 34, your address val underscore output.
34, line 34. Okay, yeah, they're right there.
Where do you call your PID loops? You've defined them there on 34 or 33. Where do you call the loop?
Where he says where you're instantiating them.
Oh no!
I believe that PID my PID underscore R is the
I can take you into
that's otherwise that's where the instance begins.
That's the setup, but that's not the loop call.
Right.
Right.
Okay, the loop call will be down. Let me see if I can find it. There's a lot of stuff going on here, so.
That's the
Yeah, we need to see the loop.
It is right here, I think. This turn right there, there's U-turn.
Wait a minute.
I
don't see any. All I see in the loop is digital read high and digital read low for the button. There's no loop here yet.
Where?
You're line 100 or so. The Arduino loop.
Yeah.
Right after setup, you had Arduino loop.
Okay, yeah, I see the right side.
Okay, you see this distant U-turn?
U-turn, yeah.
That's my function.
Um,
And it's down here, right
It
here.
hasn't.
yeah, there's
And
your
it
problem.
uses this right here. Huh?
You have a 2-second delay in your loop.
Oh.
Yes, I do. Well, that's just when I when I hit I got a button I push to hit it, to start it. And when it hits it, it goes into this while loop right here.
Oh, okay, so yeah, there's the
It
while
goes
loop.
into a while loop. See that?
All right, yeah.
So it doesn't even go back up to the void loop. It just hangs around in that while loop till it's done.
Right, okay, so the while loop is the loop, basically.
It's the loop, yeah.
Yeah, so we need to look at the U-turn loop.
Okay, U-turn
Yeah.
function is here. It's right here.
You're calling U-turn. Where's the U-turn you call, though?
What's the function?
Where's it defined? But he dropped.
Yeah, function definition.
He dropped. Bad network.
Yeah,
Bad timing. I think we were about to figure it out.
That's probably why.
yeah.
There
Oh, here he is.
Welcome back. Hey, if you could reshare your screen. We were feeling it, Michael. We were right on the verge.
You're muted, Michael.
He's getting there. Look at that. Awesome. There it is. Void U-turn 222.
Okay. So, okay, there he's computing the PID left and the PID right. So that's good. And the result, duration count clear. I don't see where he's setting the motors, though.
Yeah, I don't either.
Yeah, that's what I was saying. Mike, go to your motor. What makes your motor turn?
Is that the advanced left? Advanced L?
It's not in mypid_l.compute.
Okay, let's just say I'm going straight. My PID loop is definitely working. So when I'm going in a straight line, you see this void forward?
Yep.
Yep.
That's what makes me go in a straight line, and that's what I'm using for straight line.
So motor advance_L is forward. So it does
It's
advance
forward.
left and advance right.
And these talk to let's see, where does it go?
Oh, is that where you drive the motors? So advance_L sets the motor to go forward.
Yes.
Yeah.
Yes, and
Okay.
I can tell you, that's another function. I can take you down there.
Yeah, let's
Yeah.
see that.
Let's look at that.
There's advance L. It's just motor on and off. And advance right.
Analog right.
And see, there's my,
PWM
see this right here, this value output L. You see the value output L?
That's
Yeah.
the
That's
PID loop.
PWM, I think. Huh? That's the PID loop.
PID loop output.
Okay, that's what it should be.
But what's this analog? So you got digital right, left.
Yeah.
low.
Analog right is how you
Okay.
do a PWM value.
Yeah, that's a PWM.
You generate PWM with that statement.
He's
Value output.
So have you checked the types, like that it's integer versus float versus? Because I remember seeing a set point as a decimal number, and I don't think the analog right would take a decimal, would it?
If you use a float, what's the other one? A long
Yeah.
in Arduino. What's the other float in Arduino?
double.
It's a double.
Well,
It's a double.
It's a double. Yeah, all of the PID parameters are doubles.
Yeah, there's a double. See that right there? Double. Duration.
The PIDs are doubles, but the PWM I thought was an integer.
Yeah.
Oh, what?
Yeah, and what do you
Well-
have? Another question I might ask is, what do you have? You should have a range. I can't remember what the command is, but in the PID loop, you have a range that you can allow the value to go to.
Oh, the range? Well, I don't know what that is. You see line 33? There's set point right there. See it?
That's your reference.
Yeah, but that's also a double. So you've got doubles in and doubles out from the PID loop, but I'm still hung up on, I think that the PWM value needs to be an integer. So you'll need, I think you want to do an explicit cast from a double to an integer.
I think that would definitely be the right way to go, Carl. But I'm also thinking he might not have his limits for his, otherwise he may be, let's say he may be sending, say, 289 to his analog write, and in that case it would actually be sending 289 minus 255.
Wow.
Yeah, the value of the duty cycle, it's the pin and the duty cycle, and duty cycle has to be a number between 0 and 255. Allowed data types integer.
Yeah. Hey, I mean, has anybody
it's gonna get weird if you don't do that, right? Because then you're going to get modulo math and there's some really unpredictable results.
Yeah.
Okay. Where's?
Yeah, you can look up in Arduino.
Yeah, set point R is a double. I got it set as a double. But I think that was that in this I stole this code from a DF robot.
Well, there you go. That's the problem.
DF robot's pretty good.
I didn't steal all of it. I took some code off of one motor. There's one motor and example, and I built on it. Is what it did.
Yeah. Well, it's still bothering me that it sounds like it was working going straight forward, but isn't working when you turn. So I'm wondering if there's something with negative numbers or something. How are you doing the reverse?
Okay. All right. Okay.
When he's going forward, they're both getting the same erroneous, strange casting from double to float, right? So they're both getting the same value, whatever that happens to be. So the gains, none of it makes sense until you get rid of this modulo math between double and float.
Okay.
Yeah.
You got to get number types straight first.
Right. Yeah. Don't you mean, well, floats and doubles are the same.
He meant integers.
Yeah. Yeah.
Let me show you. I got this.
Michael,
reference code. Yeah.
Hey, Michael, before you go,
I'm not going anywhere.
Can you show me where you set the output limits? Otherwise, that's one of the PID functions. Set output limits. Do you have that?
It's set 8. I don't know.
Well,
I don't know where the limits. Can you see the screen right?
Yeah.
It's an option.
Okay, so this is DF robot?
Right. Yep. Seen it.
Okay, so you see their set point is a double.
Yeah.
And the output
they have to be. They have to be. All of the things going into the PID library have to be doubles.
Okay.
Yeah, ins and outs are doubles, but you got to convert it to the.
But when you use it for your motor, it has to be an integer.
Yep.
And that's what everybody is saying. But you can limit if there is a setting there, where you have mypid _r set mode equals automatic. You see that? Okay. Well, there's another thing called.
Here. Okay.
It's called.
65.
Yeah.
It's called set output limits.
Oh.
Okay.
Set output limits.
Yeah, with the S, the O, and the L.
Let's find
I don't think he's setting the output limit.
Okay, I'll put the.
Yeah.
See, Michael, what was that back function I saw?
Back function. Oh, now you're challenging me. It probably just means reverse. It means reverse.
Yeah, you have a forward.
I'm just turning the motor in reverse. There it is, right there.
Okay, you're just turning the right motor in reverse. Oh, I see.
The right motor in reverse for to use the angle or do the U-turn or whatever. So
Yeah.
all that was. So did y'all figure out what I need to do with my code now?
Yeah,
Maybe
we
take
need
up the
to put in the list.
Can you pop down to the loop function
Yeah.
again? I thought I saw something there that I just want to look at.
Go to the loop.
Loop.
All right. Now, let me try to explain this to you. You see this if digital read button is low? That's a button I push.
Oh, those are.
And I've got a lot of these commented out. So if I turn them all on, this would actually go in the straight line and turn around and come back. So you follow what I'm getting?
Okay. Yeah. So those are high level functions, a disk U-turn, and so that's why there are delays in there. Thank you.
Yes. That's just in between different functions. Yeah. They call it a high level when it's in the void loop. Is that what they call that? High level function? I don't know the term.
Yeah, sure.
All right. So
That's where most of them would be.
take away from all this for me?
Well, the key thing is you're going to have to clean up this code you've lifted to start off by getting a cast and from the double to the integer. And then the other thing is to figure out, we got to get a link for you for that library reference, but like Doug posted in the middle of that list is the set output limits. So when you set up the PID controller library, you want to tell the PID library to limit its output to values that the PWM can accept. So like 0 to 255.
Okay, it turns out that it will by default be 0 to 255. I didn't see that, but so that's probably a non-issue.
Really? What will be? But where does it get constrained, Doug? Which function?
It's in. Otherwise, if you don't set it, the default is 255.
In the PID library?
Yeah.
Oh.
I didn't. I should have known that, but I didn't. It's but that was one concern I had. So, Mike, if you go down to that analog right,
that doesn't take a double though, does it?
Takes an integer.
Yeah.
No, that takes an integer.
Well, no, wait a minute. If I remember right, I thought it was 255 integer double.
It takes the output of the PID loop, whatever that's going to output.
That's a double.
I just looked it up in the analog, the Arduino reference. It says an int.
Yeah, so that's a problem.
I need to get rid of that double?
No.
Is that cast into an int and constrained to 0 to 255 somewhere?
We'd have to look at the library, but that's what this set output limits tends to say. Is that it's 0 to 2.55. So I suspect that it handles it as a double. You know what I'm trying to say?
But you're still going to have to map like a plus or minus, because the set point is your set point plus or minus some value where 0 is 0 velocity, or
well, here my on line 22 and 23 set point left or right. I put that float in there because it made it work better. Whenever I would adjust that to a 1, like say the left is 60. You see that on line 92?
Yeah.
And if I put line 92 on 60 and put line 93 on 61, it would overshoot. It would overshoot my adjustment when I was trying to do a straight line.
It would steer to the left, I hope.
It would overshoot my adjustment. So I put that float in there. I put and it straightened it out.
That means one of your wheels is not the same. One's bigger than the other.
Well, no two motors are the same.
Well, that should have more to do with the wheels than the motors, though, because the motors are controlled by the PID loop.
Okay, so All right. Well, so I'm having to kind of deal with that issue, I guess, then.
Yeah.
Otherwise, what Ted's saying is that if you left them both at 60, the wheels would turn at the same speed. Okay.
Well,
but if one is bigger than the other one, then that one's going to cause it to arc.
Okay. Okay. So here, if I put left one at 60, and then to try to adjust that, I put the other one at 61, it would overcompensate.
Yeah. Yeah. Because it's not that big. It's not
so
that
that's
big.
why I put that point in there.
Yeah, that makes sense.
That makes sense. Yeah.
So is that a bad thing to do with that point? Is that a wrong thing?
No, the part about the integer has to do with the analog right. Which
So
I think that double will get converted to an integer when it calls that function, because that function takes an integer, and it should be in the 0 to 255 range, it sounds like.
Yeah.
So okay, the PID library, I didn't change anything in that except for my set point.
Right. Yeah, and that's fine.
Yeah.
So, but in the demo that come off of DF Robot, that's kind of what I mean. What's my point? Well, in DF Robot, it was working. Do you think that their code could be goofy?
Yes.
Okay. Thank you, Carl.
There's an old saying in engineering that applies when you're copying a design. The saying is, copy faithfully or understand completely. And
well, see, I'm not an engineer.
And you haven't understood completely either.
Okay. I'm going to put a
The
line
other
of
one is
code
you get
in.
what you pay for, so, you know.
I'm going to put
If it
in a
was
sample
free.
line of code that I've used that might help you here. This is that's how PowerSim takes
So you're casting
a
as an
double
int?
output from a PID loop, same library you're using, scales it for whatever reason, and then casts it to an int.
To an int?
Yeah, just say in parentheses int in front of whatever is a double.
Yeah, I see that there. Yeah.
I don't see
So
it.
does the library?
Oh,
Okay, I've got a C question for you. If you create a function that has a parameter as an int, and you send it a double, will it cast it automatically?
Yes.
Okay.
But
There
will
you
it
go,
do it the
second
way you
part.
want it to?
What?
Okay,
Will it
thanks.
do it the way you want it to?
Well, if it expected an int, and you gave it a double, it looks like it's going to take care of the casting for you.
well, I believe if you really look it up, and I'm not a C expert, but I think that what happens is there's certain castings that are allowed, okay, and they're kind of the ones that you most normally would expect. But there are some castings, I believe, that it won't cast, and so you have to explicitly cast. Okay, so I think it's good practice to if you're going to do that, if you're going to be changing the scope of the variable, then you should explicitly cast.
And you may not get what you expect casting. If it's 8-bit integer and you pass it 10,000, well, you're going to get something strange.
Yeah.
Yeah. Yeah.
Oh yeah, so I didn't show you somewhere else I have, and that's where Doug talked about the limiter. So if you limit the output of the PID loop, then you'll know you have a valid value in the right range, although it might be decimal.
Yeah.
Okay.
Yeah, I don't know. Since it's been says they did it to the default of the Arduino analog write, I'm assuming that they do the cast inside the library. So that's probably like I say, a non-issue.
But I might need to research that, I guess.
Yeah.
Or
I mean,
may throw
but I got to admit
compiler
that
error.
but if I were writing myself, and I was going through it, I would make the explicit cast because, usually I wouldn't go look in the library to find it.
Like
It probably helped if I knew what I was doing. That'd probably help a lot. So.
Yeah, well, we all have
Yeah,
that problem.
I think Doug's on the right track, and it's overly broad to say that C will change the type of a value automatically. C will automatically upcast, meaning it will automatically cast to a type that is of higher resolution. So a char will automatically be upcast to an int. An int will automatically be upcast to a long, but it won't automatically downcast. So it won't automatically take an int and downcast it to a char, or it won't automatically take a double and downcast it to an int or a char. It doesn't know how to do that. So what you're really doing is you're handing a function that expects a 4 bytes as an int, and you're passing it 8 bytes that are a double. The first 4 bytes of which are perhaps, I think the first 4 bytes of the mantissa. So that's going to give you like some very peculiar results.
Well, it's a number less than 1, right?
You're muted, Ray.
I am.
You have to.
Oh,
You have to
it's
think
a number
about-
less than 1, right? The
You're still
mantissa.
muted, Ray.
No, he's not muted.
I'm not muted.
Was it me?
I hear Ray.
Yeah,
You have to think about the variables as memory, a memory location, right? And Paul's exactly right, because when you say you have a 32-bit entity and you're assigning it to an 8-bit entity within C, well, it's only taken 8 bits, right? So basically, you're talking about a memory reference versus a value, right? And then you start looking at the endedness of that memory location, right? Because like when you're recasting it, you're telling it, okay, take this memory region and look at it as an 8-bit value, not a 16-bit value or a 32-bit value. And the same goes for like signed and unsigned, right? It's just a value in memory. How is that value represented in memory is what you're really doing when you cast something as a double or a float or whatever. And Paul's right again, where, a double is going to have the integer part and the mantissa part. And I think it has to do with the memory organization, or which one's in front and which one's behind. But so that's basically what you're talking about when you're recasting, or you're automatically quote unquote casting, is you're really just truncating or having a larger bucket than the bucket you started with, right?
Yeah.
So my question is, you think my code is messed up?
Well, not like that.
No,
Just
I wouldn't.
clean it up.
I mean, you're going in a straight line, right? So
Yes.
that's good.
Something's
That's
working.
good. Yeah.
Okay.
What I'm not so clear to me is how you're turning around and how you're setting direction.
Basically, when I turn around,
Whoa. Like, for example, usually if you were just doing a PID loop and all of a sudden you change the set point from 0 degrees, well, I don't know. In your case, you said it 160 and 1 minus 60. Okay.
Right.
So it's just going to turn. It should turn pretty quickly.
What I'm doing is I'm just reversing the motor on one of them.
Yeah,
I'm just telling the motor to turn the other way.
Yeah, but okay, but you should be able to do that by just setting the set point to the negative value.
Okay. But
Okay, that's what you see what I'm saying. The set point is what you want.
okay, so my
Yeah.
question, but
The
let me ask you
input
this.
is what you got, and the output is a corrected value.
But Doug, the code doesn't care. I mean, which direction I turn that motor. I'm just telling it to turn the motor the other half in reverse.
Yeah, but I'm just saying is to keep it consistent in your mind and not having to make special cases and stuff.
Oh, I got you.
You see, this way you only change your set point, which is
Okay.
another name for set point is reference. When I grew up, that's what they called it, reference. All right, and that's like I say, that's what you want. The input is what you got, and the output is the corrected value. Okay.
Okay. Let me ask you.
None of those necessarily. The input and output are not necessarily ever 60. Do you get me? Like the first time you went through, it's probably 49. Okay. So it goes 49, it goes up, and it says 49 from 60 is 11. You know, I've got a gain value, so it's 11 times the gain value, and that's the output. When it goes, shoots it out. It might be 80 for all I know, because it's going slow, so it should be higher. And then when it comes back, and all of a sudden now it's going faster than you want, it should flip it around and reduce the value.
Well, see, when I make a turn like that, I do it. I use a delay, so I stop everything.
Okay.
With the delay, and then I go to a different function, and kind of it's a totally different, you know.
This is a little strange. Now, I'm just throwing this out because of personal experience. In that library, when you've got a loop that should be very consistent. Sometime it looked like you were set at 100 milliseconds, but whatever it is, it should be that all the time.
Right.
You shouldn't suddenly interrupt that loop for 2 seconds. Now, what you can do is you can turn off the PID. You can go to I forget, whatever is automatic, you can make it manual.
Yeah, that makes sense.
You make it manual, and that turns off the PID. And then you can sit there, and then you can turn on the PID again, and it will try to correct to what your new reference are.
All right, that makes sense, because it kind of resets and everything's calmed down. But let me ask you this, like the same question at the beginning of this whole thing, is running these motors at a low voltage like that at a low cycle of the PDM, that could have an effect on it too, couldn't it?
Well,
yeah, if it's so slow that
it's almost at the stall.
Make the motor move, then yeah.
If you don't have enough control range.
But usually that suggests that you're in ballistic at that moment. Otherwise, if your PID is active and you're saying, unless let's say you said go 15, it should try to go 15.
I understand that. It's trying
it might be kind of jerky because 15 might be too low for that motor.
I got you.
But
it's trying to keep up with those encoder ticks. That
whatever you're telling it to, yeah.
And
especially if you have a high I value, it's if it's not seeing the number of ticks per interval, that I value is going to keep increasing until that motor actually moves.
And you could get some jerkiness out of that, right?
Yeah.
Well,
so then you're probably going to see an overshoot or
maybe
even
especially if you're using an I and you don't have the output limits constrained, like Doug suggested. So if I could suggest, Mike, so your gearing idea sounds good because that'll get you in the voltage range that the motors won't stall on you. But I'd also suggest you just do a sit down with paper and pencil and try and do something like this. And like what I did on the robot was that I said, if I have so many encoder ticks, because that's what your set point is, I think, your 60 or whatever you're trying to
set. Yeah, 60.
so many encoder ticks per period or whatever.
Let's see, what is that? Encoder ticks is different than the set point.
Okay, so then you might need one like this where you have a bunch of, so you want to have you want to have a column for set points, you want to have a coder for encoder ticks, and you want to have a column for motor PWM.
Right.
Okay, and then you got to just figure out, all right, if I have this motor, if I have my set point from this high value to this low value, then what does that mean for encoder ticks? High value,
got you.
low value. And then what do I want for the motor PWM?
Makes sense. That makes sense to me.
I guarantee you that if you force yourself to go through this, and then if you just trace through what the code is doing to try and map this, it's going to help you get the mapping space straight.
Right. That makes a lot of sense to me. Because I have no idea what the PWM is right now during that time. So
it's not real important, Mike, that what the PWM is. It's doing whatever it takes to get you the number.
Oh, okay.
Yeah, but on the other sense, I'd push back on you, Doug, because if a little calibration will go a long way. If you know that on maximum PWM you got so many ticks per period, and on the slowest your motors can go, you're having trouble at the slow end. So set the PDM, just put it up on the bench where the wheels spin.
Right.
Put it get the wheels spinning as slow as they can go, and figure out, okay, what's the lowest PDM I can spin unloaded, and then
in fact, that's
between the low PWM and the high, and that's going to give you a range of control. Outside of that range, you're not going to get it. It's no
okay. That makes sense.
Carl, I'm building on your idea. This is because this is exactly what I told them. What you want to do is put it up on the stand. Run, all it is just a simple command, sending analog write at 10 or 20 or whatever it is.
Right.
And map your motor response. Unloaded. Okay.
I actually have done that.
All right. Okay. Now go back to that article we talked about that's a couple weeks back. Change the PWM frequencies and find out which one gives you the best.
Okay.
Okay. And use that one.
All right. I'll tell you what's going to happen though is if I do all that, which I don't mind doing all that, I probably won't make this time around 6 cans. So
well, there's 2 other contests.
Okay.
There's 2 other contests. Contests, and both of them are they all give the same prizes. So go for it.
Well, that helps out a lot. Sure appreciate that. That helped me a lot.
So I've got some code to show you. I just wrote a short C program to do some implicit casting, and it seems to work that you can implicitly cast a double to an int.
If it's in range, right?
If it's in range.
Yeah, if it's in range. If it's not in range, I have no idea.
Yeah. Well, go ahead. No, hey, Ted. Well, since you have it all set up, make it go to 256. What do you? Wait a minute. No, wait. You're using an int. Make the int a character.
Yeah.
Okay, and force it to be to cycle over.
All right.
Okay. All right. So 35 is good. That'd be fine.
There you go. Nice big number.
Yeah.
To make it really valid, though, you should put like point something, 0.5 or 0.6.
Yeah. There
it went to 79.
Yeah. See, so that what it did is it rolled over.
Give it a something. Give it a 60.35, like he had in his code.
60. Okay. 35.
There you go.
Same thing.
Yeah.
Yeah. 60. So it just rounded it down.
So it rounded it down, but the big thing is, and so.
But big numbers get weird.
Yeah, big. If you get over 255, then you overrun the integer, and it's going to be.
Yeah.
Just for grin, give it a minus number. See what it does.
Okay. We give it minus 1.35.
Okay.
Probably a big number. Nope.
Yeah,
-1.
just -1.
Huh.
Why is that? I thought a character was an unsigned value. Am I
Well,
wrong?
an int by nature is signed. So if
Well,
you cast it to an unsigned int,
Yeah.
Yeah, and it's the printf is converting it, so I think
Yeah.
that's
Okay. All right.
Yeah. FreeNep is.
well, and when it gets over 255, right, you're still just getting the last 8-bit or the first 8 bits, right? So the value above the 8 bits, or 255 in this case, is basically being thrown away. So what you're doing is you really have modulus division by 255 at that point.
So it'll just give you 255 and that's it. What'll it do?
yeah. If you set it to like 257, it should give you like a 1 probably. I'm testing that now.
Well, I think that'd be a 2, wouldn't it?
Let's say it's a really bad random number generator.
Yeah. So,
Well,
let's see what,
I've used that technique as a counter before, because if you say you have a 32-bit counter, right, and you want to drive some other function at some given period in that counter, you can just look at the counter as an 8-bit integer and say, is it 0? Right.
Yeah.
So as the counter rolls over every 255, your test becomes true, and you have a periodic event.
I just tested it, and 256 is 0, 257 is 1,
Okay.
which sort of makes sense.
Yeah.
All right. That guys, that was a lot of help. Appreciate that.
Good question.
Yeah.
Yeah, well, it kind of kept me from throwing my hat in, from throwing in the towel, playing on this stuff.
Well,
That's
You
what
know,
you're
Mike- Michael, your code, if it doesn't work, it's broke. You asked that question earlier, and
I appreciate that.
the reason is if it doesn't work, it's broke.
And if that's all the help we can give you, okay.
I'm just here to help.
Okay, I think we had next in queue, we had Ted, Doug, and then Pat, then open mic.
Okay, so I am next in queue. All right, let me present here again. Let's see. There you go. So this is my outdoor robot here. And I put in some blocks here to keep it from rotating too far, and then some rubber bands. So I just kind of wanted to show you that picture. And let's see, this video I just kind of went around and showed different parts. But then I have a video of, hold on, stop this. I have a video of it going up and down some stairs. So I got that working. I was kind of excited about that.
But not bare wooden stairs, I hope, because that's going to chew them up like crazy right now. Your wife would kill you. Who put all these scratches in the staircase?
Yeah, no, this is outside.
That's looking good.
Yeah.
Is that a
Awesome.
gold star?
Gold star.
All right. And that was not autonomous. I just want to point that out.
A silver star?
That's still good.
But then I have, let's see, another one here somewhere. And this is proof that I'm in Colorado, because you'll see the snow on the ground. This is last week. So my other problem is demonstrated here, that there's a center of gravity issue.
I thought it was the snow, Ted. The
Yeah.
snow caused it. It slipped.
Yeah, we'll just call that the snow.
Yeah.
Yeah.
Yikes.
And boom, it's upside down.
Yeah.
But
So what were the rubber bands supposed to do? Just limit the thing from flipping over?
the rubber band makes it so that it keeps the front two wheels on that pivot more balanced, so
Okay.
it will go, if it, you know, if the front wheel goes into something, it'll help it push up. Because
Oh, okay.
before it was getting, the problem was it would hit like the step, and the front wheel would try to go down, and the
Mhm.
back, it would do strange things. So
Can you like single frame through, or at least like rapidly stop that fall sequence so we can see the dynamics of
yeah, let's see.
what actually
Go-
causes it?
Go to settings and go to settings and set the speed way down.
Yeah, okay.
25. Yeah, there you go.
0.25. There we go.
Oh,
Yeah, you can see the front just goes down and everything goes over.
But look what's happening. The front wheels are folding under.
Yeah.
Yeah, and
Why it's flipping.
yeah, actually, and that's a good point. And oh, maybe that was before I put the yeah. Well, let's see. Can I see if there's? I'm looking to see. Oh, the rubber band is there. You can see it's just on this front one. I eventually moved it to the back. So
I wonder if that's a speed related issue. Like if you really launched it, you know, with the front wheels, keep
Yes.
up with the.
see, it did this first step okay, but and it almost flipped over there. So I
Front-
might need to add more rubber bands just to keep the front from going under so much.
Oh no!
Oh,
So the
front
front
bogey.
wheels were vertical, and the top just collapsed over top of it.
Yeah. And yeah, I think you're right. That's a good point. If I had to lift the front wheels more, then it wouldn't be as likely to do that.
I was thinking, or if you went a little faster, it wouldn't, you know, just like fold over. It would probably launch itself right over the.
Isn't that how you dodge the rain?
Yeah,
Full speed ahead and damn the torpedoes.
just go faster. Yeah, and let me bring up my other tab here. So no, that's this one. Okay, here it is. So on this one, I did have to, and part of that was the rubber bands again. I had to take off some of the rubber band because I was having kind of the opposite problem climbing the stairs, where it would flip over backwards because, you know, the same thing was happening, just kind of in reverse, where the front wheels would go up too much and then it would flip over backwards. Let's see. Yeah, so there you can kind of see where it's climbing up. And if I went too fast and I had too much rubber band on that front wheel, it would pull back too far and the whole thing would flip over. I think it's just kind of a center of gravity problem, but I can't do a whole lot more about it because I have the batteries and everything fairly low on the frame. And going in reverse like that, I think it did slightly better because I've got the wheels that pivot left to right going down first.
I think with David Anderson's platform, you know, he does have travel on the suspension on each wheel, but he seems to like ride on the edges of the step. So like once he gets up, it goes like from edge of the step to the edge of the next step, you know, kind of in a.
Yeah.
So
And I think with this design, I might fiddle around with limiting how far those wheels can articulate, and that might help. But I think this is about as big a step as it's going to be able to climb over. So I might just have to be happy with it. You know, bigger wheels might help too.
That's very cool.
Yeah, thanks.
Very fun.
Yeah, the Go Builda parts are great for this because I use it like an erector set, and I just take stuff off, move it, screw it back on. So
You just have to get over that initial multi-$100 investment.
yeah, exactly.
What happens if you lengthen the chassis?
Well, if I lengthen the chassis, I kind of have to make the chassis wider also, so I get the turn radius geometry is correct. Otherwise, the wheels on the corners are skidding a lot. I mean, I could just decide to live with some skidding.
Nice job. Gold
Yeah.
star. Yay.
It's good to see somebody. Yeah, that's awesome. Cool. I think we had in queue next Doug, then Pat, then open mic.
Okay. Oh, just give me a second here. I'm trying to find a number, and it's not doing it. Okay. Oh, I'll go ahead. All right. If you guys will pin me. All right. So, all right. I got to show you this. You know what that is?
It's out of focus.
It's out of focus. That's true.
A connector.
Connector,
It's
yeah.
an connector. It is a Grove connector.
Oh.
And the little pin on the Grove connector was put on by me
Ooh.
instead of, and so what I wanted to share with everybody is this. This really looks like a very good, in fact, I think it might be the best, whatever these are, crimper. Yeah, best crimper that I've run into. You can not only do the good DuPont connector pins, but it can even do the crappy Chinese DuPont connector pins. And it can also do the Grove command. And so
You have a link?
yes, I do. And give me a second here.
Yeah, those are great.
And it's very reasonably priced too. It's only $26. And let's see, here's the link.
So, Doug, I have a crimper, but I always have trouble getting the wires and the connectors into the crimper and aligned.
That's right. And I do too. I've got like 5 crimpers.
Yeah.
And they all do that.
Yeah, they all have the same problem.
Except this one.
Awesome.
Okay.
Yeah, this one works pretty good, but there's no name on it, so I don't know whose brand it is.
Yeah, I got one of those too, Ray.
Yeah. So yours, the other one works better than this, huh?
Yeah. Wait a minute, what in the world? Well, let's go, yes. Okay, and now I'm going to give you a model number because that link will show you several models, and what you want is the.
Is that like a ratcheting one?
Yeah. Well, yeah. Well, it's more. Yeah, it does ratchet, but the model is 0B13, I think. 01013BR.
I see 13BR.
Yeah. That's one seems to be, at least the one I've got, works like a champ. Like I say, I've struggled with this type of thing for I don't know how long. Like I said, I got 5 or so, and they all kind of work, and some of them work good on one type of connector, but not on another. But this one, like I said, this is the first time that I've ever been able to achieve this. So, and they slide right in, this part slide right in.
Oh.
So anyway, for what it's worth, I think that you might like it. So anyway, you can unpin me now. Boop. All right. That's all I had, Coral.
That's pretty cool. All right. So then we got Pat and open mic.
Hey guys, so I've been having trouble with steering control on my robot. I'm trying to get the robot ready for the 6-can competition. Basically using a little 2-wheel frame with the yellow TT motors with encoders.
Mm-hmm.
I'm okay to drive out pretty straight out to a target point. So I set a target point of 0, 150, so 150 centimeters in front of the robot. So drive out about 6 feet. And then I change my target back to go to 0, 0, so go back to the starting point. So it should turn 180 degrees and come back. The problem I'm having is I've got a setting in there that if the angle is so great, is greater than a certain amount, then put 0 linear speed and put all angular velocity basically to have the robot spin in place.
Mm-hmm.
So it's a big change, so just spin in place. The problem comes when as I get to 0, I'll slow down, but I'll overshoot. And then when I try to correct, I undershoot. And the problem, I just can't seem to get it dialed in. It just keeps going and going. And that was using just a straight P calculation, just a math multiplication. So now I'm trying to do it with a PID to see, okay, well, can I dial it in a little better and get less oscillation using a PID?
Mm-hmm.
So I had that issue. What I did was I had actually 2 settings. So if it was a long ways away, it would have one PID loop, and when it got close, it had a different one. Does that make
Okay,
sense?
but you were using PID loop for steering.
Well, was I using?
Because I use in my motor driver in my Arduino, I have a PID loop for both wheels.
Yeah.
Mhm.
Okay. So no, you're right. I had a PID loop for the wheel speed, and then what I did was I slowed the speed down. So I didn't change the PID loop. I just changed the velocity. So if it was within like 10 degrees, it moved slowly. If it was greater than that, moved faster.
Yeah.
Has anyone tried changing the gains as well? It's like
I have tried changing like the factor of my multiplication to say, okay, well, if I'm off by so much, remove it. The other one I do is if I'm close to target, or like let's say I had it at 7 degrees. So if I'm within 7 degrees, I would allow the linear. I would subtract the angular velocity from the linear velocity and just sort of slow it down a little bit, but try to correct it. If it's greater than 7 degrees, I zero out the linear velocity and allow it to correct just with angular velocity.
One thing that I've done that might come into it, Pat, is I've introduced a little heuresis in it. Otherwise, when you engage the turning off of otherwise you got a big angle, the angle that you allow it to be big to engage turning off the forward motion is different from the one where you allow it to come back into play. So, okay, so like when I go, if the turn is greater than, I don't remember, say 40 degrees, okay, then it would kill the forward motion and start turning, okay? But like I say, it won't disengage that until it gets pretty close, and that'd be like your 7 degrees, okay? So then, but it won't come back to that. It won't re-engage that forward momentum until it gets worse than 20 or 30, whatever I said before, 20 or 30 degrees. Do you see what I'm saying? Let him run.
It sounded like you're basically trying to rotate in place, right?
Yeah.
So basically how I approach that is similar, I guess, what you're driving at is when I'm steering and driving my robot, I have two values that that control it. One is the velocity, one is the turn value.
Yes.
So like you were saying, when I spin in place, my velocity is 0, but my turn value is some number, right?
Yeah.
And that number is the error between where I'm at and where I want to be, right?
Yes.
So, and those are the two errors and parameters that I feed into my PID loop for steering. What I found though is I use the P and D terms in there because the D term is going to keep you from overshooting, right? And like Doug was saying, I have a dead zone that, and it's like 2 degrees. So if I'm within 2 degrees, I'm good. I'm not trying to get it exact. And if you're just using straight odometry, you've got real-time values, but I drive, I get my position, my direction from my IMU, from my BNO 55, like on my CAN robot. So I always know where I'm pointed at, and then once I set my demand, or where I want to be, then my PD loop handles the turn. Now what I do though is I have a variable where I can limit the maximum turn velocity, right? Because you just don't want to spin around and like you're saying, overshoot. So those are the variables that I have in my robot that I use to control that with. Because it has to do with the timing. Like with the IMU, I found that it's fairly slow, right? The update rate is, maybe 50 hertz. I'm not sure exactly what the update rate is on the BNO 55, but it's not really, really high. So you kind of have to give it time to hook up to the robot. But if you tune it right and you rotate at a slow enough velocity, then the IMU can keep up with you, and it's not that big of a problem.
Okay.
But I think you're on the right.
You're using a PD loop as opposed to a PI loop.
Well, I mean, it's a PID loop, right? So each one of those terms has a different function within the control mechanism, right? Your proportional gain is going to get you going. Your integral gain is going to get you all the way to where you want to be. And your derivative gain is going to account for any mass or any overshoot. And typically, we don't see a lot of mass or overshoot in a system like a small robot like what we have. But I found that in the turning position, once your error starts going down, and because the derivative term is the difference between your last error and this error, right? So as that number starts to get smaller and smaller, then the term basically goes away. So it helps you stop on target without the overshoot.
Okay, so you're using all 3 terms in your PID loop.
No, I don't use an integral term at all.
So you just leave it at 0 and don't use it.
Yeah, because that's but see, what I do is I kind of run a non-traditional output, right? Because I don't allow my PID loop to accumulate the output value. My PID loop is there to simply say, what kind of change do I need to make to the current value, right? So I don't, and when you do it like that, you don't really use the integral value because you're accumulating that somewhere else, right?
Okay.
So and that's really where the integral value comes in a PID loop, is your proportional is the difference, right? And your integral is what your history has shown, which again, I take out, and because for me, it's easier, like, especially when you're controlling a PWM, your PWM is at some value already, right? And that's how you got to where you're at. So the stay to either get to where I want to be or stay where I'm at or stay where I want to be, then what change do I need to make, right? So I don't confuse that change with the integral term. Now you could use it again if you have a lot of mass in the system to help either keep you moving, to overcome the momentum, because sometimes when you're almost at set point and there's not much error to work with, then you start to sag, right? And so now your error starts going up and up and up, and then you're going to recover. Well, that's where the integral term comes in at to try to stabilize that. But it's just a little bit different way of thinking of a PID loop to collect the term external and just have it identify what change do I need to make. Because it'll still drive you, like if when you're 180 degrees out of where you want to be, right, as you're starting to turn around, your error is really big. Right?
Yes.
Your proportional term is going to basically take over everything because you've got this huge error. And that's where the turn limit is going to help you from over speeding, right? So you limit the overall speed value when you're in that function. In other words, like even when you're driving forward, you really don't need a lot of difference in your turn, right? So you have different turn values. And like I found, I have, for different behaviors, I have different turn limits. Like for instance, when I'm navigating outside, right, my turn limit is really, really small because I don't want to be driving around, like a drunken sailor. So I limit that. And you may drift off course, but you're going to, as your error starts to collect, you're going to pull back in. So, and like when I'm turning on the can course, after I've collected a can or something, I can turn a lot faster at that point than when I'm driving, right? Because you have these different limits that you're going to need at different times. And if you
and I'm sort of looking at that as well. So I've got the forward velocity of whatever 20 or 30 centimeters per second, in a forward velocity. Can I turn faster than that? Well, right now I'm having trouble turning slower than that because I keep overshooting no matter what on my turn. And that's where I'm trying to say, okay, well, what do I do? For a straight
the first
partial gain isn't working. Well, then I'll introduce a PID loop and see how I can try to dampen that a little bit.
Yeah. Well, like I said, you can kind of control the step or the error like that. David has where he limits each step as well, right? I think he calls it a skew limit or something like that.
Yeah, so that's where the rate of change per amount of time.
Right. And I kind of handle that by just say, okay, I'm only going to be able to turn this fast with, when I'm in this behavior is what I call them. Like navigating versus, I rotate the target is one of my behaviors that I have. So anytime that there's different limit values, it's a different behavior for me, is how I handle it.
Okay. Right now, all I'm working on is a navigate behavior, essentially, at this point, just to try to say, hey, let's get to this, let's make a turn, let's do what I need to do so that I can get to the point of, hey, okay, now I'm searching for a can. And like you say, well, there you're obviously, okay, well, I have a different speed rate of turn if I'm searching for a can versus just navigating.
Yeah. But, you really also have, the foundation of all that is a good motor control, right? See, if you're telling your motors to do something and they're not really doing it, then everything else is just frustration. So, it sounds like your motor control is set, but, a lot of times I've gone back and it's like, well, this isn't really reacting the way I expect it to. And that's what's causing this other behavior, right?
Yeah, that's what I was doing while we were talking is I went back into my motor control and I bumped up the gains and to say, okay, well, can I get a little quicker response, a little better response out of my motor tuning? and to see if that made a difference. But right now, I'm not sort of seeing it. But it looked like my PID loop just quit. It was working. It was working one way, and I said, it looks like it's actually correcting the wrong direction. So I inverted it, and now I'm getting 0 output out of it. So, okay, what's going on? I got to figure that out. And that's a simple multiply by -1, and I took away the minus sign to multiply by 1, just to invert the direction for my error. And all of a sudden, I got 0 output for on my rotational value. So,
Well, that, you know, I think that's what Michael's having trouble with is the relationship between the positive and negative value of your error and an overall positive value of PID. Of course, saying that you don't have phase differential set up, but I think that's a different discussion. But yeah, I mean, that's always a challenge, you know, and I think the steering example is another good one because, you know, I use negative is turn left and positive is turn right.
Yeah, and that's what I'm using as well. Negative is to turn left. So when I say set my rotational velocity to a negative value, I should be turning, you know, looking down at the robot, I should be turning counterclockwise.
Yeah.
And the other one I'm using is real world values. So if I say go 20, it's 20 centimeters per second.
Yeah.
Well, what I was driving at was, you know, you have, you know, negative for left and positive for right, but the value coming out of your IMU is 0 to 365, you know, so, you know, there's a lot of head scratching of, well, when is this a you know, when do I need to convert it and how do you convert it? I had a bug in my software for a long time. It took me forever to figure it out, of how to calculate when I was at the boundaries, you know, 0 and 180. How do you represent that? Is that, you know, a minus or positive? And I was counting it as part of the positive side, but there were times where it would turn the robot the wrong way. And it was really showed up in my obstacle avoidance, because I would think, okay, the robot is coming up to something on its right, so it should turn left to avoid it, and it turned right into the damn thing. So it, you know, that's one of the more difficult parts is getting, you know, that kind of math and those connections put together without some sort of bug in it.
Yeah, right now I believe I've got plus and minus 180. I think I've got it right, but that yet to be determined when I'm going through and trying to keep away from a wall or something. And
Does that mean you have 361 values though?
That I'm not sure of. We'll find that out.
Here's a flow chart to help you kind of resolve these issues here. You know, does the damn thing work? You know, this one's kind of X-rated, I guess here.
It's exactly it. So when I start using the same motor control logic that I was using on my other robot, and it was working well, I did the UMB mark, going around and, you know, left and right, counterclockwise and counterclockwise, and I was getting good results, good values out of it. Okay, I'll just port the code over to this driver and be off to the races. And I thought I'd be long past here by now.
I feel your pain. You know, the robot I've been working on, you know, I cut and pasted code into it. Now it's running on the, you know, the STM32 instead of a Cortex. But, you know, I figured I'll just have to, you know, change the touch points to the HAL driver and, you know, it'll all work. Yeah, no, not so much. Because I also went from, I changed compilers. I went from the Kyle compiler to a GCC compiler. And so it looks at, you know, negative numbers differently. The other thing is I went from the encoder, you know, the built-in QEI encoder to having my own timer interrupt, you know, counter thing using the ST timers. and so now I don't get the same values that I did. So it took me a while to finally track all that down. I got it working just fine, and it was hauling ass across the floor, and the motor started smoking. I found out that my motors are only 4.5 volts, and I was running them on 12. So, I had to.
4.5, 12. Yeah.
It's only
It
on
ran really fast for a short period of time.
I'm running 6-volt motors on 12 volts, so
Yeah.
it's but I'm only at about 50% PWM on them. So
Yeah.
So you really,
I had to dial this back to about 20% of the available PWM to not over voltage the motors, but there were some really nice Maxim motors too, so I didn't want to burn them up.
Mm-hmm.
But
well, those yellow TT motors, even the encoder ones I got, I think they were about $8 each,
at
$8
least,
or $10. And so when I look at that and say, okay, well, if they only last through the competition,
Right.
fine, it's cheap enough that if you could replace it with the same motor.
Yeah.
Where did you say you were at in your progress for 6CAN? I mean, have you got a sensor that what are you using to see your cans and things like that? You that far?
I've got a distance sensor. What is it? What's it called? It's a little time of flight sensor, and it'll go out to I think it's 150 or 200 millimeters, like 6 inches or 8 inches. And I've got it located. It's an I2C sensor, and I have it located. I don't know if you can see this little green light.
Yeah.
Yep.
Yeah.
So I have it. You can sort of see the sensor there. It's from Adafruit, and it's just in the middle of my can grapple. And so as I get into that area, as I see the can, I confirm it's there, close in on it.
Mm-hmm.
What's the kind of angle that it views? How close do you have to get it before it that you don't miss it? What's the view of angle? The angle of the view.
The angle is fairly narrow, but the can grab is fairly big. So as I'm coming in, I'll see it. I've got other sensors as well to detect where the can is.
Oh, okay.
That's just to say, hey, close in on the can, you're there.
Have you checked to see if you get a return if you measure if you're pointing at the center of the can, you should get a return for sure. But if you're pointed off to the side, maybe it glances like a mirror. Have you checked?
I had using the clamp wide open like I had it. I moved the can over to one side and to the other side, and that's with the metal can. So basically, I haven't taped it yet.
No, So even there,
and
it works.
I was getting a good result. So
Cool.
I have some tape. So that'll eventually happen. We'll tape the can and get it going. So I can detect the can. I can grab the can. I have to be able to navigate to the can.
So did you say that sensor only goes like 6 inches or so?
Yeah. It's what are those? The VL6801 or something like that.
Okay. So are you going to hunt around the course looking, because you...
No,
you
I'm
can
not
only
using that one.
Oh, okay.
So
you're using something else then too?
Something else.
Okay. It's like you're a blind robot and you got a little short stick,
Exactly. A 3-inch white cane out the front of the robot isn't going to help very much.
No, that's what I was thinking.
Short stick.
It's a little whisker feeler.
Yep. It's a cockroach antenna,
No, that was just the final. Hey, the can's in position. Grab it.
yeah, I'm kind of surprised that a time of flight sensors doesn't have a more range than that.
Oh, I picked this one because it's got a small range.
Yeah, but let's think about this, because the beauty of a time of flight is that it's calibrated in distance, right? So even if it has a really far range, as long as it can measure close in, you can say, if it's bigger than a certain distance, I'm going to ignore it because I only want to measure things that are in the gripper.
Yes, but it's the short range as well. Is to be able to get close without having to set the sensor back 3 or 4 inches in the robot.
Yeah, that's what's good because it's hard to get them
The
when they're
dead band.
super
So
close.
this
and
one
super
had
far.
it's like 20 millimeters or something. It's very close. So that's why I picked that sensor, because of the not the far distance, the close distance. So I can see the can all the way into when it's clamped into the claw, and I know how far away it is. Whereas to say, oh, I'm in the dead band there now, so I have no idea where it is.
You should use one of these, the little switch with a thing on it, and it works really well. And 0 power.
Yeah.
Yeah, it's gotten you second place several times.
Yeah.
It's great if you want second place, huh?
Oh no, that's not why it's second place. It's an 8-year-old platform with slow motors. So
so that's my story. So this week is going to be a mad scramble. It's been there's been so many other things that have cropped up in the last week. I had a furnace die, and so it was a main board on a furnace for $1,000. And well, what caused the relay to go on the main board? It's probably the motor. That's another $1,000. So then I said, well, you know what? It's $2,000, and I have a 18-year-old furnace. So change the furnace.
Yeah.
Yeah.
And when I do that, well, let's do some ductwork. Well, then with the ductwork comes some drywall. And then my part-time work interferes with the rest of my time, and I scramble to get programming time in for the robot.
Well, at some point you just say it's time for new house, right? Just move.
Exactly. Time for a new house. No, we did a lot of work on this one. We gutted it in 2009 and redid electrical, plumbing, ducts, air, floors, ceilings, walls. So
Everything but the furnace.
I put the furnace in the year before. I put the furnace in 2008. So,
Wow.
And 15 years later, it's dead. And that's the lifespan of a furnace nowadays.
Yeah.
So, anyways, that's not a robot related problem. So tomorrow, the last of the drywall mudding, the guy is here. He's going to finish it all. Work is getting under control. So robots are starting to take priority here.
Cool.
That's it for me.
Nicely
Thanks
done.
for the help, guys.
Good work.
I think that was the end of our scheduled queue. So now we have open mic time.
Oh, hey Ted, have you ever used the PIV control in the basic micro motor controller?
Did you say PID control?
No, PIV. It's for position control.
Oh no, I've just used the velocity control.
Okay.
I did have one issue. There's the PID control was acting strangely, and I did an update to the firmware, and that fixed it.
Yeah, I have an older unit and a newer unit, and the older unit I can only go up to revision 1.34. And but the first time I tried to upgrade it, the thing just went nuts. I don't know what it did to it. It just like made the motors run at full speed no matter what you did. And it's kind of like, okay, had to actually go back to a legacy version of their IDE and reload version 1.34 on it. So, but it's working again.
Yeah.
Yeah, I didn't realize it, but if you think you have an issue with your unit, like you fried it or whatever, got a motor stuck and ran too much current through it or overheated it or whatever, you can actually send it back in and they'll refurbish it for you.
That's good to know.
So,
How much does that cost, Ray?
I think it depends on what you destroyed. If it's, maybe 4 FETs or something, a lot less than if you give them a piece of charcoal that,
Yeah, I gotcha.
Yeah. But if it's $150 controller and you can
Yep.
fix it for 30,
Yeah.
That reminds me of that scene with John Candy and planes and cars and whatever, trains and whatever. You know,
Planes,
where
trains,
he's in the burned out rental car, and he gets stopped by the cops, and he says, "You know, do you know how fast you were going?" No, officer. The speedometer's broken. Surprisingly, the radio works. That's a classic John Candy scene.
yep.
Yeah.
So Carl, I have a question, I guess, for you and Doug. Since I'm not going to make the contest, let me know how you want to get this this course from me. We need to meet up somewhere, or how you want to do it.
Okay. What part of town do you live in?
I live over in the Mid-Cities area, over by Keller.
Okay.
Yeah. You're closer to Carl.
Closer to me than Doug.
Yeah.
I'm actually out next week, but after that, we can figure something out.
Okay. Yeah, just reach out to me and
Yeah.
figure something out.
Do we have the date nailed down? Is it what is the date again?
Second week, whatever it is.
Second Saturday?
The
Yeah.
13th.
13th.
Yeah, has our little storage area moved to somewhere else? I haven't been to the makerspace in probably a year.
I was there a month or two ago, and it was still there.
That's good. I think John would have let us know if anything had disappeared.
He would have, and you know, when I had my after my shoulder surgery, I went in and I put labels on the shelf, so they should be calling Doug, you or me, or Steve or John. I think
Yeah. Good.
should be.
Should be. Well, they usually. Never mind. I'm not going to go there.
Yeah, who knows?
Yeah.
Hey, Michael, did you have quadrature encoders on your robot?
Yes.
Okay. And you might
And
just double.
I only use one. I don't use. Well, I use 3. It's a long story.
Okay. You might check that your directions are correct when you're doing the PID loop.
Well, I only use one sensor
Oh, okay.
for each motor.
Yeah, so direction doesn't matter to you.
Right.
Right. Hey, well, it looks like we're winding up for the night a little bit early, but if there's nothing else, I would move to adjourn. And then, Doug, I got a question for you. If you could hang on for a second.
Okay.
So if there's no other topics, all right. Sorry, guys. Hopefully in May I'll have something to contribute, but for now I'm not much help.